Hello everyone, I'm Mohit Puru, and today we are here to discuss our PTSP seminar. And my topic is understanding stationary random process. And today we are going to see what is stationary random process and what are different types in it. And my name is Mohit Puru. I'm from class ECEA and with roll number 411. And this seminar is for the semester second year semester 1 and mid 2. So what is a random process? What is a random process? Random process is a collection of random variables indexed by indexed by time or space, representing phenomena that allow unpredictably. So random process contains random variables, collection of random variables. It is a process which also has a probability, and the common examples are include stock prices, noise signals, temperature changes, and we are going to find a probability and apply some all exhibiting random behavior over time. And visualization, random process can often visualize it by as trajectories or realization that vary due to inherent randomness. And next, we are going to see the classification of various random process. And here, discrete and continuous random process. The discrete random process means the just like an impulses means the graph or the wave which it was not continuous, but in the case of continuous it's just like a smooth curve, every point will touch in it, like for example continuous we can give as example as temperature change. We can even we can measure at any time the temperature change, so it is a continuous process. It just doesn't uh, vary discretely. And to the main stationary and non-stationary processes. In stationary processes, the statistical properties remains constant and do not change as the time proceed. So stationary processes, the values don't change with respect to time, like the mean, variance, covariance, etc. It doesn't change with respect to time. They are independent of time. The process is independent of time. So the those type of random processes are called stationary processes. And the processes in random processes which are dependent on time are called non-stationary processes. And their in contrast to non-stationary processes which display characteristics that evolve over time, reflecting a dynamic nature, reflecting a dynamic nature. So here we are also Markov and non-Markov. Markov processes are characterized by their memoryless property. This means that the future states does not required or the process rely just on the current inputs. Non-Markov processes are required even on the not only the current inputs, they also require future inputs, future outputs. And next, definition of definition of stationary process. Stationary process is said to be stationary if it is mathematical properties, statistical properties such as mean and as I said before, mean, variance, and do not change with respect to time. So implications where these are implied. Stationary simplifies analysis, modeling, since the same statistical principle can apply regardless of the specific time of which observations are made. Types of stationarity. It is essential to distinguish between strict and weak stationarity, stationarity, and practical purposes. So, types of stationary in this main strict stationarity. A random process is a strict stationary if the joint distribution of any set of time indices is invariant to shifts in time. So the joint distribution of a time indices are invariant to shifts in time. Even in the shifts in time in place, they should be invariant. The random distribution of any set should be invariant. Weak stationarity. A process is weak stationarity if it is mean is constant and it is auto covariance only depends on the time difference, not the actual time points. So, for weak stationarity, in case of strict stationarity, the joint distribution function indices are invariant to the time shifts. In case of weak stationarity, mean will be constant, and the auto covariance only depends on the time difference, not the actual points of where the it only depends on a delta t, not on the uh, t or the current time where the points are taken. And the application, different types of stationarity have varying applications, particularly in statistical interference and signal processing. So next, mathematical formulation for strict sense stationarity. uh, Understand actually for strict understanding the joint distribution in probability theory. In the context of strict stationarity, it is important to note that the joint distribution of any random variable and unchanged even when subjected to shifts in time. This characteristics is known as is fundamental in understanding the behavior of stochastic process. And essential mathematical notations for stationary processor: p of x of t1 comma p x of t2 and so of x of t of n x of tn equal to p of x of t1 h plus h t of x of t2 plus h and so on x of tn plus h holds true for every value of h. Even if the h value changes, the value remains changed. So the equation here, the value will remain change, holds the true value for every value of h, and applies universally for chosen sets of time points conserved within the stochastic framework. And the practical example of stationarity is strict stationary is while a noise process. Characterized by its complete invariance, it remains unaffected and it remains unaffected and consistent regardless of the time frame or period under consideration, making it an ideal representation of a concept in action. So next one, mathematical mathematical formulation for wide set wide sense stationarity. The process x of t is weakly stationary if E of x of t equal to nu, means if the mean is constant and the covariance x of t1 x of t2 equal to x of t1 minus t2, sorry, c of t1 minus t2, then it is a weakly stationary. And variance of x of t remains constant over the time. Thus, variance of x of t equal to sigma square for all values of t. And weak stationarity is often sufficient for many applications. Uh, Nobody in time series analysis. And importance of stationary importance of stationarity in applications. Statistical interference. Stationary process allows to consistent estimation of parameters critical in modeling and forecasting tasks. Signal processing. Many algorithms in signal processing assume stationarity to affect filter and analyze signals. And also an application simplified modeling stationary process simplifying the mathematical models making them easier to perform analysis and draw conclusions. And the example of a stationary random process, the white noise, a common example of a strictly stationary process characterized by a constant power spectral density and zero autocorrelation. And Brownian motion, a weakly stationary process where the uh, where the increments are independent and are normally distributed, widely used in and they are widely used in modeling. ARMA models, auto-regressive moving average process (ARMA). Auto-regressive moving average model process exhibits weak stationarity under certain conditions, make them useful in time series forecasting. And next slide. So next one, uh, no, non-stationary non-stationary random process. Non-stationary random process are uniquely defined by their evolving properties at time progresses. This properties which encompasses variation in mean, shifts in variance, and changes in autocorrelation. Present significant complexities in their analysis, especially when compared to stationary process that maintain consistent behavior over time. And definition, here you can see the definition. The process are those whose statistical whose statistical properties change over time, affecting whose statistical properties change over time, affecting mean, variance, autocorrelation. As I said before, the stationary random process doesn't affect the mean, variance, or covariance with respect to time. But here, the non-stationary process are those statistical properties change over time, affecting mean, variance, and autocorrelation. And any alternation leads in key aspects such as mean, covariance. This inherent variability poses a challenge of for accurate modeling and prediction. So the examples of non-stationary process, a prime example of a non-stationary process is temperature data, which frequently shows significant seasonal fluctuations. So the temperature was not constant in every season, not similar in every season. It varies from season to season like summer, winter, rainy. And it is a major example for this non-stationary random process. This variations in temperature over different seasons leads to time varying mean and covariance, highlighting the process non-stationary. Challenge in analyze the challenges in this non-stationary random process analyzing is the presence of non-stationary process poses considerable challenge in statistical analysis and modeling. Analytics frequently need to apply transformations to utilize differencing methods to convert and this complex process into a stationary ones, facilitating more accurable interpretation predictions. Moving on next slide. Checking for stationarity. There are some tests we can check for stationarity, statistical tests. Techniques like ADF tests and KPSS tests are used to test for the stationarity in a time series. And visualization, plotting the time series can be indicate stationarity, trends, and changes. You can simply understand these things by plotting a graph, time series data graph, stationarity, trends, so that from them we can understand the stationarity, trends, changing in variance, non-stationarity, etc. And transformations. If a process is non-stationary, differencing, retrending may be applied to achieve stationarity for further analysis. And applications. What are the major applications in engineering and science? Telecommunication, stationary random process, model signals in channels, helping for design about communication systems, etc. And economics, finance, stationary is a crucial modeling for stock prices. So even the stock prices, the graph, it was not a stationary. It's a crucial modeling stock prices. Even the graph, next point, whether the graph reaches high or low. Sol and user, all this was set by stochastic process and modeling stocks, interest rates, and economic indicators facilitating accurate risk assessment. Major who are the experts in this stock marketing? They already know the whether the graph may goes high through these processes. By applying this theory to that and environmental studies in climate modeling, even in the weather conditions, this process was used widely. Stationary process can simplify the analysis of a time series data related to various environmental factors like cyclone, sudden rain, etc. They're also set through this stationary processes. And next, the summary of a stationary random process. So, what are the major key takeaways? The stationary random process are integral to probability theory and statistical modeling. So, they are both for probability and statistical modeling. And types, differentiating types between strict, what we have learned today is strict and weak stationarity. Importance, stationarity enhances reliability of statistical conclusions and predictions. And next, and that's it. Thank you.